Hello again, YouTube. The last time we just used this setup with this cinnamon bun and a small, my little Vero board, 2 LEDs, a switch, D0, 1, 2, and then I've got this logic analyzer, the 8 channel logic analyzer connected to D3, and that's ground is the other connection. So I've just got ground, and we were using that to look at hardware timers. So we'd taken the bare bones example project, which is in libesoup on GitHub, and added the configuration option for hardware timers. So we added hardware timers into the system. I wanted to do, moving on from that, I wanted to do software timers, add software timers into the mix. But if I do a git status of this, I've actually edited the main bare bones project, so I don't want to. That's an example project which I don't want to commit back up because we're adding hardware timers to the bare bones. So I actually want to. We'll just create a new project that we can actually play on here locally. That's not going to be. Yeah, it's nothing to do with. This isn't something that we'd want to commit to that repository, so I'll just create a new pick 33. So I'll create a new project, a new standalone project. Pick kit 3 and XC60. No, cancel. Just the current XC16 I have. My network connection's kind of all over the place, and we'll stick it in a home directory, mplabx projects, and call it. We'll just call it my bare bones because I've really taken this from the actual example project in libesoup. So if I now go to my bare bones. I usually like to make a source directory. So we'll copy that example main bare bones into our current directory, the one that we edited. We're not going to commit that back. So, and we'll take the configuration file. Sorry, we'll take the configuration file as well. So our source directory will have the configuration for libesoup, and I don't seem to have a connection at the minute. No, I'm struggling with a connection, so I'll leave that, and I'll just then just copy that whole libesoup manually from my local file system into this current directory, and then actually get a status, and I'll just I don't really need to do that here, but just in case, I don't want to commit changes back to that project which are not really anything to do with the project. So now we have our main file, our header file, our configuration file, and we've got the library. So if I go to this new project and add a source directory, and we'll just add the source directory, that's my bare bones source, and that will hopefully add a lot of stuff. Now we can get rid of the documentation, and we'll have to get rid of the examples directory because that contains a lot of main entry points, and the compiler will moan about that. So we can get rid of most of the other stuff, and any of the other directories in there that I haven't got rid of, like the jobs and utils and status and the comms, because they're not switched in our configuration file, because they're not included in the build because of the configuration, they're not going to get compiled. All of those files have switches on them. So I want to move from what we had, which was adding hardware timers, and I want to include in this build software timers. Now, hardware timers, I said last week that they're limited by the number that they're included in the silicon. So you may have a couple of 16 bits, you may have a couple of 32 bits. There's various configurations or whatever. It depends. It's obviously hardware dependent, and they're a limited number. So one of the things that is done is you create a software timer, which is based on a single. You take one of the hardware timers, you create a single timer that becomes your system tick. In the Linux kernel, it would be called a jiffy, I think. So you talk about jiffies. So we want to add a software timer, which is part of this libesoup, into the build. Now, it's not going to work because for a start it can't find libesoup. That's to do with my new project. I have to tell XC16 GCC where the include directory is. So include directory is this source directory, right? So that's the first thing. You've got to get an include directory set up. The next problem you're going to have is that, unlike hardware inclusion, when you include software timers, you've got to include or define the number of software timers that your system was going to use. So the software timer module will keep an array of timers and keep track of those. So let's say we're going to use 10 timers. So the software code will maintain a list of 10 timers. The other thing we are going to need is this. The build that's going to fail on this is that we have to define what our timer is, what our timer tick. Now, I've only ever used 5 milliseconds. So that's, to me, has been more than sufficient. I could actually probably stretch it out to 10, 25 milliseconds. I've never really started a software timer that is of that short as a duration. If I'm going for microseconds, like a really accurate 200 microseconds, 100 microseconds, then I use a hardware timer. Whereas this 5 milliseconds is more than accurate enough. There is a granularity issue there. Obviously, if you've got a 5 millisecond tick, you can't create a 7 millisecond timer. You'll either have a 5 or a 10. So there is a bit of a granularity issue there. But like I say, I've never acquired anything more accurate. I've only ever tested 5 milliseconds. If you wanted to change that value to 1 millisecond, then it should work. So now, having done that, we can include our software timers header file. If we actually replace the hardware timer in here, so if I replace that header and just call the call to start hardware timer start, I can just change that to software, because the two APIs are identical. They both take this request structure. So instead of microseconds here, we obviously can't start a 200 microsecond timer because we've got a 5 milliseconds tick. So we'll go with a milliseconds, 200 milliseconds repeating timer, and we'll just do exactly the same thing. We'll call our expiry function. So it's an event driven system when the timer expires. And previously our while loop did nothing, which is great. it works. But in this case, this is a software timer, so we have to, I should have gone to, where did I go to the header file? Because this is a software timer, we have to assign processing time to actually work out, has the timer expired. So in our while loop, we just want to call check timers. So a hardware timer will interrupt every 5 milliseconds. That will create assert a flag, and check timers will just go around and say, has the timer expired? Has the timer expired? Has the timer expired? And if the timer has expired, it will then go through its table of timers, of which there are 10, and say, has this software is this timer even in use? And if it is in use, increment a counter and see, has it expired? And it's all managed by that check timers. So now if we build that, and if I drop it into my, if I flash it into the unit here, the cinnamon bun, hopefully we should have so we've got exactly the same configuration in terms of we've still got our logic analyzer connected to pin D3. Now previously we had our 200 microsecond repeating timer, so we got a square wave. If we run this again, we should have where will I check this? I'll stop that. We should have about that's the 200. I should actually zoom in, maybe get it a bit more accurate, but that's our 200 millisecond repeating timer, and that's a software timer. And you can create, because it's only using one hardware timer, you can create any number of software timers. Now obviously there are limitations with a software timer. So for example, if I've defined the timer tick to be 5 milliseconds here, so if in my main I check the timer, if I then do something here which is, if I do 25 milliseconds of work, then my 5 milliseconds timer, I'm never going to hit a 5 millisecond timer. So this main, the while loop, the main loop of your application should be short and sweet. But 5 milliseconds is an awful long time when you're running at, like, our instruction cycle is up at 60 megahertz, so that's a lot of instructions in 5 milliseconds. But you're not, like, there are limitations with software timers, just there are. So you can't get 7 milliseconds because of your tick is 5 milliseconds, and you've got to keep your processing sort of small in that main loop so you can get back to check has a timer expired. The other thing is the hardware interrupt, this expiry function. In a hardware timer it would have been called from an interrupt routine from that level, whereas the software timer will actually be called from this routine, so it's actually in the normal, it's a normal, at a normal run level sort of thing. So just keep that in mind. And that's it. That's software timers. It's just exactly the same request structure as for hardware timers. The units, the duration, the type of timer, either a single shot or repeating, and the expiry function, and any data you want to pass. That data will be passed into this expiry function. It's never really, well, I've never really used it for much, but I have used it, but we'll get to that. And that's it. That's simply a change to software timers. And if I go back to, because of my structure now, this would be a more normal structure. I've got I can do whatever I want with these files, my library configuration and my main.c, and libesoup isn't going to change. And I can still pull that repository every now and then to get the updates from it. But yeah, that's it. That's the simple software timers. Thanks a million for watching, and I'll see you again soon.